Hello, everyone. We are on our prob stats unit, so this will last a couple of weeks. It's a different looking package than you usually get, or a pack of notes. On it, you should see where it says prob stats on the top, and you've got kind of like a grid of everything we're doing. You need to ignore what it says like day 1, day 2, day 3, day 4. This was created for a block scheduling, and we are not in block. So it'll take a little longer than what it says, but follow the Google Calendar and you should be fine. So make sure you have your probability and statistics notes out. It should say sample unit outline on the top. It should say unit 11, even though it's just prob stats. All right, here we go. All right, when you're looking here, we're going to do permutations, combinations. This is our first section. This is not right notepad. Hang on. Let's see where we're at. Sorry about that. There we go. It should say probability and statistics. We're doing permutations, combinations, then theoretical prob, condition and prob, binomial theorem. You are going to take a quiz over all of those. That's what quiz 11, this says 11-1, so it's their 11th unit first section. Okay, and then we're going to do measure as center and z-scores, and then these two will be on this quiz. After that quiz, we will review and have a test. All right, let's get moving. All right, when you're looking through here, it sounds easy, but a lot of times when you put it into practice, it's a little harder than it is. So the first thing I'm going to start with is the fundamental counting principle. This is what this is called. If decisions M can be made M ways, so lowercase n, and decision N can be made N ways, then the two decisions, sorry about that, can be made, and you just multiply them together, M times N ways. So let's do the first one together, and then you do the next three. The ice cream shop offers a choice of 3 cones, 15 flavors, and 8 toppings. How many cones are possible if you can only choose 1 flavor and 1 topping? So what you do is you take the 3, so you have 3 different cones, 15 different flavors, 8 different toppings, and when you multiply that together, you get, calculator, give me a second, 360 different cones that you can make if you work at the ice cream parlor. All right, pause and do yours. This one was a little different. License plate consists of 3 letters followed by 4 digits. So let's look at this. We have 3 letters, I'm going to draw lines, and 4 digits. All right, there are 26 letters in the alphabet. So there's 26 options for the first one, 26 for the second, and 26 for the third, because it did not say I couldn't use duplicates. Digits is like 0 through 9, so there's 10 options for each of those. So when you multiply that together, you should have gotten 175,760,000 different combinations. This in here is tricky. As a section with 12 true or false questions, how many different ways can Nick answer these questions? Well, the first question has 2 solutions, right? Because I can do true or false. The second question is 2 solutions or 2 options. The third is 2 options. The fourth is 2 options, and so on, all the way until we get down to the 12th one, right? So that means I have 2 to the 12th power because I have 12 2's. A whole lot easier than writing all those out. And you should have got 4,096. The Clayton family enters a 4-digit code. How many codes are possible? 4 digits. So remember, it did not say they could not duplicate. So in your 4 digits, you should have had 10 times 10 times 10. So in other words, 10 to the 4th would be a little bit easier to write this, which is 4 zeros. So 10,000 different codes. Right, that is the fundamental counting principle is what we're talking about here. Next, we're going to move on to factorial, and this is actually just notation. So when you do factorial, a factorial symbol is an exclamation point, and there's always a number in front of it. So a number, factorial. Okay, this here is the product, sorry, of all the natural numbers from wherever you're starting to 1. So 9 factorial is 9 times 8 times 7 times 6 times 5 times 4 times 3, 2 times 1. You multiply all those out, you get 362,800. You have a factorial key on your calculator. It's under the button PRB if you have a PRB button. All right, so 12 factorial, I actually want you to give me the answer using 12 factorial and also show a little bit of work. So you know that that's 12 times 11 times 10 all the way down to 1. And when you plugged it into your calculator, you should have gotten 479,001,600. Okay, pause and do the rest. 8 factorial, you should have gotten 40,320. Okay, 17 factorial over 11 factorial. Make sure you show some work here so you I know you understand. So this is 17, 16, 15, 14, 13, 12, 11, 10, right? Well, 11 is 11, 10, 9. What you're showing all the way down to 1 is that this and this cancel. All you're really doing is multiplying 17 times 16 times 15 times 14 times 13 times 12. And your answer should have been 8,910,720. 0 factorial, by definition, is always 1. Okay, now you know what a factorial is. Permutation, it is written NPR. All right, an arrangement or lineup of objects in which order matters. So what that means is it is different, like ABC, if we had those 3 letters, right? That is a different permutation than BCA. Even though I have the 3 letters, they are in a different order. Order matters. Okay, it's NPR is how it's written. You actually have a permutation button on your calculator. It goes n factorial all over n minus r factorial. All right, important shortcut. If it's n over n factorial, well, that's n minus n, so you have 0, and 0 factorial on the bottom is 1. So this in here is just n factorial. All right, how many ways can you arrange the letters in the word dinosaur? Well, when you look at it, dinosaur has 8 letters, and I want to choose all 8 of them. So R is how many you're using, N is how many you're starting with. So out of my 8 letters, I am choosing all 8. The way we do this is we do, so this here's our shortcut right here, so that's just 8 factorial. You can type that into your calculator, 4,320. I'll recognize it from above. Okay, pause and do yours. There are 7 students who are competing in geography B. How many ways can they finish first, second, third? So I want to choose 3 of them. So this is 7 permutations of 3. And when you look at it, that's 7 factorial, following your formula up here. 7 factorial, how many I have? All over 7 minus 3, so n minus r factorial. So the 7, 6, 5, 4, 3, 2, 1. All over 7 minus 3 is 4, so 4 factorial. So this cancels, so you're left with 7 times 6 times 5, which is 210. The other way to do this, I have first, second, third place that I want to choose. For the first place, I have 7 people. Well, if I chose one, I only have 6 left. If I chose another one, then I only have 5 left. That is why your permutation works. Oops, I went too far. Let's go back up. All right, I want you to pause and do your 3. Okay, it says 4 classes. How many ways can they be arranged? So I'm doing 4 classes. She has to take all 4. So this is just the 4 factorial, or the shortcut, which is 24 different schedules she can have. There are 16 players on the baseball team. How many ways can the coach make a 9-player lineup? So 16, order matters because it matters if you're batting first or second, right? Permutation, I am choosing 9 of them. So that's 6 factorial, or 16 factorial, over 16 minus 9 factorial, which gives you 756 when you plugged it in. 28 students, how many ways can the students elect a student council, representative, and an alternate? So there's 2 people. So out of the 28, I'm going to choose 2 because it matters which direction I am doing that. So that's 750, okay, I'm sorry. 28 factorial, all over 28 minus 2 factorial, which equals 756. All right, permutations with repetition are a little bit different. And we could do the great big long formula, but we're just going to go straight to the shortcut. Okay, when we look at automobile, there are 10 letters. There's a 10-letter arrangement, right? So I'm going to choose 10 factorial because that's what I'm starting with. All right, using the letters in the word. It says I'm going to use all 10 of them, but there's 2 zeros, or 2 O's, I'm sorry. Nothing else multiplies. So whatever the doubles are, I divide by that many. So that was 2 factorial. So if there had been, I don't know, let's just pretend there was 3 A's, right? Let's put this after it. Then I would have a 3 factorial down here with the 2 factorial. The 2 would represent the 0. The 3 would represent the 3 A's because that's what doubles, and we need to take those out. Okay, we don't have 3 A's, so let's get rid of that. I'm hoping you understand. If you don't, make sure you're putting questions in the discussion board. Okay, 10 factorial over 2 factorial means there are 1,814,400 different ways of arranging automobile. Okay, pause and try yours. 9-letter arrangement. All right, we look here, D does not, I does not duplicate, S does not, A does, oh, A does. I have 2 A's. So my A's, I have 2 of them, so I have 2 A's, factorial. I also have 2 P's, so this one stands for the P's. And that is all that is doubling. So we do 9 factorial over 2 factorial, 2 factorial. That gives you 90,720 different ways. All right, that covers permutation. Remember, permutation order matters. And I decided to go crazy. Okay, combination is NCR, and this in here is order doesn't matter, or whoops, does, I can't even read that. I don't know how you're going to read that. Here we go, let's try that again. Order, here let's put does not matter. All right, so in other words, when I give you ABC, that is the same as CBA. Those are not 2 combinations, that's just 1 combination. Order does not matter. All right, it is very similar to a permutation. You start off with n factorial. You still have n minus r factorial in the denominator, but it's a lot like here where we took out our doubles. We're going to take out the ones that are doubling up, which is r factorial. And that's a combination. This time, if you have n and you're choosing all of them, there's only one way to choose everybody. So that's the shortcut instead of n factorial. All right, let's do a couple and then you go on. Natalie has 16 close friends. How many ways can she choose? 5 to be a bridesmaid. All right, we know that this is a combination because I'm a bridesmaid regardless if I was chosen first or last. Either way, I have the same title. Nothing's important, well, more important here. So out of the 16, it's a combination of 5. We put our 16 factorial on the top. I'm going to do 16 minus 5 factorial on the bottom, and then I have to get rid of all the duplicates, which is the 5 factorial. When you plug that into your calculator, you should get 4,368 different combinations that she can choose from 16 friends. All right, try yours. Okay, we have 24 kids, and how many ways can he choose 8 to attend his birthday? So it doesn't matter if he picks on 1st or 8th. They'll all be at his birthday party. So this is a combination again. He's choosing 8. So we have 24 factorial all over 24 minus 8 factorial. And then we also have to divide by the duplicate, which is the 8 factorial. When you plug that in, he has 735,471 different options or combinations of inviting friends. Abby's adopting a kitty from the pet store. There are 18 kittens. How many ways can she choose 2? Again, order doesn't matter. If she takes them home, she takes them home. Doesn't matter if they're 1st or 2nd. So that's 18 factorial, 2 factorial, 18 minus 2 factorial. Type that in, you should have got 153. 12 employees at the sub shop. How many ways can they manage to choose 4 for the Sunday shift? Doesn't matter if I'm 1st or last, I still have to work Sunday, right? So we have 12 factorial all over 4 factorial times 12 minus, 4 factorial. And when you type that in, you should get 495 different ways of assigning people to work. Football team, we have 85 football players. How many ways can they choose? Coach choose 3 to represent the team on the coin toss. So are you a captain? I want 3 of you. So we go through. I have 85 I am choosing from. I have 3 that are going to double, 3 factorial. Then I'm going to take 885 minus 3 factorial. It's a factorial there. And that's going to equal 98,770 different ways he can choose captain. Oh, why is this going crazy? Stop. Let's see if we can get back up to where we were. All right, it is. Sorry about this, people. Okay, you are on the next page. I hope you're not watching this. And you got permutations and combinations. All right, right now, I want you to pause and see if you can get these down. Okay, I've typed them in so you can see what your answers are. I did a little bit. I want you to do more work than this. So this is a combination because this order doesn't matter. When you put the combination in here, I would like to see the 30 and the 4 and then the answer at least. If you plug it into the formula and you make a silly mistake, you'll get more points. So if you show the formula work, that will help you out. Make sure you do that on all of these. And I hope you did well. Okay, the next section is your homework. I need you to give those a shot. Let me know how you do, and the answers will be posted on the website. All right, well done. Have a great day.